Hi, everyone. My name is Travis Rector, and I'm a professor of physics and astronomy at the University of Alaska Anchorage. And I'm also one of the organizers for a group called Astronomers for Planet Earth. And today we have Dr. Brian Siana, who is an astronomy professor at the University of California, Riverside. And he's also the Associate Director of Sustainability at UCR. And he oversees the sustainability curriculum and research there. And I know he's going to talk with us today a little bit more about what's going on at UCR. And so in addition to answering questions about his presentation, which he gave 2 weeks ago, he's going to, I know he's going to talk with us a little bit more. So I thought we'd start, Brian, with just some of the questions that have come up since your talk. So first off, your talk was awesome. And I've gone back and I've watched it a few times, and I've shamelessly stolen a few of your slides to add to my own. And so given credit, but I still have stolen them. And so, you know, what I just want to say, what I really like about your talk is it gives a clear path forward. I mean, it's you know, it's not often when people think about climate change solutions, they think of, you know, fantastic technologies like nuclear fusion or carbon sequestration, or things that just, you know, don't exist yet, at least not on an economically viable level. And what's really remarkable is you presented in your talk is how realistic this is. I mean, we can do this with off-the-shelf technology. This isn't a fantastic moonshot or something like that where we need to do new things. And so one of the questions that came up in the Q&A on from your video was about heat pumps. I mean, heat pumps, unless you live in Alaska, are a really, really good idea. Incredibly efficient. And the question was asked was, they're ubiquitous in Europe. What's with America? Why don't we have more here? So do you have any insights on that?
You know, I think my age might limit my ability to answer that question. There is people generally older than me often have heard of heat pumps, but they have a very negative view of this. And the way I see it, the way it is, people thinking about electric stoves, they're thinking about, you know, the previous generations of electric stoves, and they're thinking about the previous generation of heat pumps, and when they were, you know, inefficient and breaking down and left the heat pump. But, you know, electric stoves, resistance electric stoves are slow and, you know, have a lot of inertia, thermal inertia and whatnot. And so there's a lot, it's hard to change minds once people have been introduced to a bad product. I think that's part of it, right? That the newer technologies, the newer efficiencies in heat pumps are really great. But I also think that there's been a multi-decade campaign in the United States to promote natural gas as a clean fuel, not in climate sense, but in, you know, pollution sense. You know, clean natural gas with that beautiful blue flame. You know, there's nothing negative associated with it. I mean, it's literally on our buses. You know, it says, you know, this is a clean natural gas bus. And there's been so we've got a lot of natural gas in the United States. And I think there's been just, you know, decades of promoting gas as a clean fuel, and even amongst climate people as a bridge technology to decrease carbon emissions. And so there has been no real kind of pushback until recently against natural gas. You know, coal, you know, we've been pushing it back against it for decades, but natural gas, it's a new phenomenon to be critical of that. And it in the United States, and it's changing quickly, and people are like, wait, what? I mean, I heard such good things about this 5 years ago, like from the Obama administration, right? So what's going on? So I think it's a partly propaganda, partly old technology, and partly cost. Natural gas is very, very cheap in most places in the United States. And I mean, it's very cheap where I am. And so the benefits are not as high for electrification.
Interesting. So, I mean, speaking of natural gas, and you know, I honestly don't remember if this was part of your talk or if this is something seen elsewhere. My understanding is that when you take into account the leakage from the extraction and delivery of natural gas, it's actually pretty much just as bad as coal as far as the greenhouse gas impact. Is that what you've heard, or do you know much about that?
Yeah, there's a lot of debates about exactly what fraction of the natural gas leaks, whether it's 1% or 3%. And depending on what time scale you're looking at the warming, if you get a few percent leakage, then all of the greenhouse warming benefit is gone relative to coal. And I don't know the answer to that. I do know that when people look at kind of holistic things, not like at one source, like at the well or along the pipeline or whatever, when they look at broader things, like there was a study over the Los Angeles basin of methane in the air, and they just inferred that actually quite a bit of methane must be leaking, from sources in, like our hot water heaters, right? And it must be, a few percent. And so the benefits are not so obvious. Yeah. And in any case, it's becoming less and less of a bridge fuel and more of a, we're going to have to be shutting down a lot of natural gas power plants very soon. And so building new ones right now, or new natural gas infrastructure, especially in our buildings, like I've discussed in my talk, for heating, seems really like a bad investment, right? That we're going to have a lot of stranded assets, right?
Mm-hmm. Mm-hmm. Thank you.
Since we're on the subject of heat pumps, I was wondering if I could ask a question.
Yes, please go right ahead.
Yeah, I mean, I am one of these older people who has a negative view of heat pumps, and I know that they apparently are not very good when the outside temperature is very different from the inside temperature. I mean, as Travis was mentioning about living in Alaska, so heat pumps apparently aren't particularly good in those cases. I mean, are they getting better now? Or are you still recommending heat pumps in those extreme cases with extreme environments?
Yes, this is a great question. Yeah, this is a good part, a good chunk of that negative view. Heat pumps now run, and when I say run, I mean, of course, you can just run electrical resistance through it and get some heat, but that's what you're trying to avoid, right? But they still have benefits now in the newer heat pumps. There's these cold air source heat pumps that run down to kind of -20 Fahrenheit. They really, I mean, with some benefit over resistance, not much at that point, right? But so there's no doubt if you're in an extreme climate, that's going to be a problem. But if you're in something like Europe, where mainland Europe, not northern Scandinavia or something, but that's a pretty modest climate. If you've got temperatures down to thanks for the conversion. Down that low, it's almost the same. I just it's a twiddle about the same. But if you're really 0 degree temperature, 0 degree Fahrenheit, so maybe, I don't know, maybe -15 or so. If you're down at those temperatures occasionally, then that's fine. So yeah, there's no doubt that it matters. Like I have a heat pump here, and the average temperature it's running in is 50 degrees Fahrenheit. Again, you can do the conversion, but it's like 10 degrees outside, 10 degrees Celsius outside, and it's extremely efficient, right? It's providing 4 or 5 times more thermal energy than electrical energy needed. But I have, like, my father-in-law just bought a heat pump, and he lives in central Maine, right? That's kind of the most extreme weather temperature you can get in the continental United States. And he loves it. And it works pretty well, actually. And he does supplement it when it gets down to, negative in Fahrenheit. He will supplement it. He has a wood stove that he runs as well. But now he was going to put in a propane furnace, but I convinced him not to at the last minute. So it's pretty good. Yeah, so there's no question that I brushed over these details in the talk, but I think for the vast majority of people, it is viable now.
So after your talk, Brian, I did look online to see, what the status is for Alaska, because as you mentioned, in colder climates, once you start getting down to, you know, 0 degrees Fahrenheit, minus 18 Celsius, that sort of area, that they start to become so inefficient that you do need to, that it's actually more efficient to just use an electrical heater as part of that. And these units do have that. What's interesting, I think, is that I was not able to find an analysis for Alaska that was newer than 5 years. And so one of the big questions, not for you necessarily, I have, is just, how much are things changing? Do you know if the technology, because I mean, like solar and wind, I mean, the analysis for 5 years ago does not at all reflect what the conditions are now. Do you know if heat pumps are continuing to improve, or if that technology is kind of fully matured?
I don't know the details. I do know that one kind of interesting improvement has been the refrigerants. Actually the refrigerants in our air conditioners and heat pumps are terrible global warming gases with like global warming, warming potentials that are several thousand times carbon dioxide per molecule or whatever. And or I don't know if it's per molecule or per mass, but whatever, a lot. But actually a lot of, I believe it's cold water, on a cold temperature in particular, people are starting to use CO2 as a refrigerant, and which has a warming potential of 1 because it's all relative to CO2 rather than a few thousand. And it's apparently more efficient if you can run it at the right pressures and everything. So I think there are advances coming. I think a lot of the advances are actually in software. I know that's crazy, but in California, what we want to do, we have right now it's sunny outside, and it always is. And we have tons of solar potential, and we have tons of actual solar energy right now. And if you can run the thing when the grid is clean, it's really, really valuable. So hot water heaters, right? If you have a heat pump water heater and you run that thing during the day when the electricity is clean, and then it's thermal storage, and that's super powerful. So California is really on board with this, and now they're going to put in massive incentives for just changing out every water heater for a heat pump water heater. I'm going to change mine in the summer, and then what you do is you overheat it. You overheat it by an extra 10 degrees Fahrenheit or so, and then you have a valve, a thermostatic valve that ensures that the temperature coming out is still whatever you want, 120 degrees Fahrenheit, even though it might be 135 inside the water heater. But then you can allow it to flex, the temperature inside to go up and down, and you only heat it when the electricity is really clean. And I think that's incredibly valuable. The big thing that we need is energy storage, and thermal storage in our hot water heaters is enormous. And so I think that's really powerful.
That's interesting. I haven't heard of the idea of using our own water heaters as a energy storage capacity, but that makes perfect sense. So we have
do it in our. Oh, sorry. Go ahead.
Oh, go ahead.
I was just going to say we do that like at the University of California, right? We have the reverse, right? We're trying to cool our. We have a central plant that cools water and distributes that cold water throughout, hundreds of buildings. And what we do is we need to run it in the evening at 7 p.m. in the summer when it's really hot, but we end up pre-cooling that stuff, at before 4 p.m. while the sun is up. The electricity's cheap, the electricity's clean, and then we shut it off. It's good for the grid. It's good for our energy bills, good for the climate. So it's really valuable. Yeah.
So we have quite a few people here, and I'll just say, if anyone has any questions they'd like to ask, go ahead and feel free to raise your hand, or you can actually just unmute your microphone as well. So does anyone in our gallery have any questions they'd like to ask? William, you have your hand up. Go ahead.
Right, thanks. One of the things I liked about your talk was you addressed so many basic things that I sort of realized, but I didn't really appreciate. And that was how heat engines are being used so much. That the system, I knew it had waste, but there's a lot more waste than I had realized. And that's really an important point. But I was thinking this whole talk was focused on energy and how we're supposed to get off fossil fuels. And of course, that's important. But there's a whole aspect to carbon, getting carbon under control that most people don't talk about very much. And this is an idea that's been coming out a lot lately, and that's regenerative farming, because agribusiness, for example, destroys the surface soil and throws up a lot of carbon into the atmosphere. And with regenerative farming, then a lot of the carbon becomes sequestered very naturally, and we can produce better grasslands, better land management. And I just wanted to mention that, and I can give a couple of links I will give to everyone, which they might find interesting. There's this documentary that you can find on Netflix called Kiss the Ground, which some of you may have seen already. Let me put that here. And that's also on the news. Let's see. Another one as well. So I hope people will at least check this out if they haven't seen it already. I think that's the entire link.
Yeah, I think my talk is entirely, beside, in addition to that, right? So these are things that I'm interested in, and I think there's viable policy and pathways to decrease carbon emissions. But yeah, I haven't addressed agriculture at all, or land use generally, and that's another piece of the puzzle. Yeah, no doubt.
And I think that brings up an important point, that when it comes to talking about solutions, there is no one single solution. And you hear people all the time say, well, we can't switch to wind because wind is intermittent, or we can't switch to solar because intermittent. And the answer is when it comes to solutions, it's all of the above. I heard someone describe it as there's no silver bullet, but there's silver buckshot.
Yes, so, I've heard that too. I really like that. I don't know. I got to figure out who said that originally.
I heard it, I think, in context of the En-ROADS climate simulator, but I don't know the origin. But I think that's an important point, especially when we talk about with people about climate change solutions, as they often, because every solution, every energy source, no matter whether it's carbon-based or not, has strengths and weaknesses. And so it's important to talk about those and understand how they can work in concert. So that's a really interesting idea of using, afternoon solar power when electricity is cheap and abundant to, store energy, whether it be in our hot water heaters or by other means. Leo, I see you have your hand up. If you'd like to go ahead and ask a question.
Okay, thank you. First of all, I'd also like to express my thanks again to Brian. This was really an excellent talk, and I also really learned a lot. I liked many aspects of it. I had one question coming back to the heating pumps. In the Netherlands and also in Germany, many people have on their houses a solar thermal heating, just some heating liquid that gets heated up. And that works in a similar way as you described for University of California, that does some pre-cooling. You heat up something much higher than you want, and then you can use that heating over many days, actually. You didn't cover that, I think, in your talk. Is that technology from yesterday, would you say? Or is it in addition to the other things? Or?
At least in the United States, it's actually, when I asked about this, when I put solar panels on my home, people were like, oh no, we don't really do that anymore. We don't. The only place I actually see solar thermal, at least in residential, is for pools, when people have swimming pools. But I think the concern there, I think at least the older versions of them had a lot of issues where their lifetimes, they required a lot of maintenance, and they would break down and clog up and whatnot. And I think at least here, the issue is with the hard water, and what you're doing is distributing this through a lot of small pathways and them clogging up and whatnot. But It's certainly viable and cheap. But if you've got your photovoltaics and you're getting 20% efficiency, and then you've got a heat pump that is getting, a factor of 4, efficiency in converting electric to thermal, and you're basically back there again, right? It's almost the same as just creating the electricity and then using a heat pump. But it's more versatile because if you aren't using it at the time, then you can just put that back on the grid. And so I haven't heard much discussion actually about solar thermal. And I think that's because photovoltaics have gotten so cheap that it's kind of winning out.
That's a good point. So efficiency is almost the same, but it's much more versatile, probably simpler and perhaps even cheaper to build solar panel power. I mean, photovoltaic panels and heating pumps. Yeah. Okay.
And if you're connected to the grid, then somebody else can use it when you're not, right? And so I guess that's the reason. I don't know.
Yeah, it's interesting. I mean, comparing America to Europe, in Europe, on-demand water heaters are ubiquitous, and you almost never see them in the United States. And our home, when we bought it, the realtor said, "Well, you're really going to like this house because it has a 50-gallon, water tank." And I thought, my first thought was, no, I don't want that at all. I mean, that's just going to be such an energy sink. And so I'm intrigued by this idea of using it as an energy storage unit.
Yeah, you need the storage for a heat pump because a heat pump provides the very little power, right? It heats up very slowly, right? And so you're not going to be like taking a shower and have the heat pump heating the water instantaneously. It's nowhere near that. So you have to have storage.
Yeah, so that's interesting. So I mean, it's curious to see how in different countries, what solutions have come upon as far as providing our energy requirements, and that's one of the issues I still find frustrating. Again, this analysis I found for heat pumps in Alaska, it talked about it from a purely economical standpoint. The carbon footprint was not at all included in the analysis, and so even if you were willing to pay more to reduce your carbon footprint, that wasn't part of the calculation. But this brings us, I think, a nice segue to, you were talking earlier about what UC Riverside is doing. So Brian, maybe you could talk a little bit about the work that you're doing. And in particular, I think we'd like to hear about how you as an astronomer got involved in the work that you do. I mean, it's an interesting career step to move into a formal sustainability position.
Yeah, well, okay, those are sort of two separate but related things. I'll say briefly my path. When I was a postdoc, I started to get really interested in climate change and solutions and kind of quantifying my contribution to it. That's what we do, right? And I lived in a studio apartment a mile from work. This was at Caltech, and I just walked to work and lived in a tiny, tiny studio surrounded by other studios, so there weren't thermal losses into or out of the home. And I was super efficient, and I was pointing fingers at everybody else. And then I got a faculty position in suburbia, and all of a sudden I owned a home that was much, much bigger, and I had quantified my energy use, right? It went up by a factor of 6 just moving into that home. And that completely freaked me out. I can show you the blog post of me apologizing to the world. And I said, I must be able to live in a way that is kind of comfortable and but also, kind of sustainable. And so I just slowly started to figure out what was going on with my own house and, insulate it better, put in a heat pump, just swap out for LEDs. That was like 5 or 6 years ago. Get an electric car, got solar panels, and just these things that slowly happened and that I was quantifying. But then I was looking at my campus at UC Riverside and seeing all the completely egregious waste, just unacceptable waste. Like I would walk into, the one of the restaurants on campus, and it was like 106 degrees outside, right? And I walked in and it was freezing. Everybody's dressed with short sleeves and everything because it's 106 degrees and it's freezing in there, like completely uncomfortable. And I looked at the thermostat and I could look at it, and it was 69 degrees was what it was set to. 69 Fahrenheit. That's really, really cold. And I said, why do you have this set there? And the people there working there were not happy about it. But then when I contacted the facilities people, I said, what is going on? They said, well, you know, we just set it like that because it can't keep up anyway. So we just, and I said, no, the whole point of a thermostat is that if it can keep up, it will turn off. And if it can't, it will keep going. Like, that's the point. Set it to the temperature you want, it will turn on. And so I waited 4 days and it cooled down, and I went in there at 8 in the morning when it was like 60 degrees outside, and the air conditioner was on at 8 in the morning when it was cold outside. And I was like, this is why you don't set it to 69 degrees. This is how thermostats work. I'm having this argument. It took over 2 weeks with somebody about the energy on our campus, while at the same time, the University of California has pledged to be carbon neutral by 2025. And I was like, you've got to be kidding me, right? This is unserious. This is, and it's kind of hypocritical. And there's this, you know, so you have some, you know, people up on top, the president of the University of California pledging to be carbon neutral, but in practice on the ground, there's no incentive and no education about how to get this done. And so I started complaining. That's what I do. I just like throw grenades. But then the people asked me to help and to actually contribute, which is annoying. But that's really when it started, right? So like 7 years ago, people had gotten emails from me and they said, well, we're having this workshop, or we're going to make this committee. And so it just slowly, I got more and more invested in it over time. I started teaching courses on energy and the environment, energy and climate. And ultimately, I just really wanted to be in the room when the decisions were being made. Because the University of California is not really going to be carbon neutral by 2025. And if we are, it's going to be sort of achieved in a way that is not scalable with carbon offsets or with renewable natural gas that can't scale to the entire society. And so, I wanted to contribute to make sure we do it better. So there's actually a really big discussion about within the University of California right now about how to make this more kind of robust, our decarbonization more robust. Maybe it doesn't happen by 2025, but maybe it happens in a way that is sort of scalable and long-term sustainable. And that's an interesting discussion that we're having right now.
So it's related to that. And this even happened to me 2 days ago. So many of my, astronomy colleagues, when I talk about climate change, they say things like, well, I'm concerned about the climate, but I'm not an expert in it. We should leave that to the climate scientists and support them. But they feel uncomfortable getting involved in the conversation. So what would your response be to that kind of comment?
Yeah, that's well, first of all, I think this group is really great for kind of disseminating some information about the basics of climate change. And, my talk is, one of the solutions. And that's really, really important. I will say the university, by the way, I've said some negative things about the University of California, and that's my employer, but they have been really good in some respects on decarbonization of our electricity, and they've been really good about education, right? So they run these and fund these conferences and workshops on kind of disseminating climate information to faculty and how to get sustainability and climate taught in courses that are sort of adjacent to the topic or related, but not necessarily a course dedicated to these things. And so they've developed resources for professors. They're working with K-12 teachers and educating them. And and with the Cal State system, sorry, there's like clouds going back and forth, and I'm getting dark, and there, I had to turn on the light. It's only about 15 watts, so not too bad. But anyway, so yeah, it's tricky. I think we just have to be annoying. We have to, so I decided to I run the astronomy seminar at UCR, and I said, okay, well, I'm going to put myself in on that. And I gave an astronomy seminar, to the astronomers and planetary scientists about climate change and the urgency of acting and what we can do about it. And it's really, I have a lot to say about this, but it's really interesting when you point out to people who care about and kind of know the basics of the science of climate change, that they're the most egregious actors in this problem. I mean, astronomers, when I was a postdoc, I flew 75,000 miles a year, right? That's crazy. It's absolutely unacceptable. And we're like the top 1% of 1% globally of emitters if we're doing that. We still, from Los Angeles to Hawaii, fly to Keck to do observing a lot when we don't need to, right? But Hawaii is nice, right? And so there's that dissonance that I think is a really needs to be addressed. I don't know how to do it in the right way, by the way. I don't know how to, I'm not, you're the problem. I don't think that works. But opening the eyes to, quantifying the contribution, I think is useful.
Well, excuse me. I think you bring up two interesting parts of it. One is that astronomers, of course, we feel like we want to be an expert on the subject we were talking about, because I mean, I would never go to a conference on planetary geology and try to present there because I don't work in the field. But at the same time, in my Astro 101 class, I teach about planetary geology. And so I think, at a 100 level, I certainly know enough about planetary geology to be able to teach it. And of course, if a student asks me a question I don't know the answer to, I'm going to say, I don't know, let's figure that out. And I think it's probably, it's pretty much the same for climate change. And that is, we know enough physics to know the fundamentals of it. I mean, if you took a stellar atmospheres class, then you know the radiative transfer you need to know to be able to to understand what is causing climate change. I think that gets to, I think, a second point, and I think is the reluctance for many astronomers is perhaps the introspection. That there's a discomfort level with learning that as a profession we have an outsized carbon footprint, and so there's believe it or not, astronomers are humans too, and we all find ways to rationalize various things. And so one of the issues, but one of the things as far as like blaming people, I think one of the issues in astronomy is astronomy, like many professions, requires a lot of travel to be successful. And so it's not fair to say, especially to early career scientists, hey, you can't travel anymore, when you need to travel to present at conferences, to do observing runs, to be on time allocation committees, give invited talks, do all the things that you need to do to advance your career. And so it's essentially the same thing, I think, as telling people that they're bad for driving to work, when that's the only way they can realistically get to work. If there's not,
the system is set up to,
So I think the saying I like is people need to make good choices, but they need good choices to make. And the system,
right,
whether it's in astronomy or if it's in, just especially in the United States, it's very, very hard to get around without a car. And it's very, very hard to be successful in astronomy without a lot of travel. And so this is an opportunity for us to look at our profession and see ways we can do things that are more inclusive, and easier. And so, getting back to our early conversation about virtual conferencing, one of the things that's been amazing is that virtual conferencing has doubled or tripled the participation, because now there's all these people who couldn't participate in face-to-face meetings, and now they can be part of it. And so there are solutions that people may feel uncomfortable with because it's different, but there's actually a lot of benefits. And so I think that's also part of it when it comes to talking about climate change. Is it's not necessarily sacrifice, like, you're
I have
going
a
to have
suggestion.
to work with less. Go ahead.
Yeah, I have a suggestion for Brian. Brian asked the question, what's the best way to do this? And I think that what Travis was saying and what you're doing is basically close to the optimal way to do it. Is you talk about, you be very open about, very transparent about saying that, we astronomers are the worst in producing carbon and using energy, and this is what we must do, and this is what some of us have achieved. We have reduced our energy output, and if we can do this, then you can do it too. So we serve as sort of the examples of what not to do, and then how we change, how we reform ourselves.
That's interesting. Okay, Adrienne has her hand up, so I'd like to give her a chance to ask a question. Adrienne, go ahead.
Yeah, this follows on maybe what you were just saying. Brian, first of all, that was a terrific talk. And one of the things that you make super clear, right, is we don't need new physics. we have solutions. We just, the implementation of them is what's so challenging in some fundamental way. And so a lot of it does come down to sort of policies, and kind of the point Travis was just making about if there isn't an alternative to how you're going to get to work or how you're going to do this thing, then what are you going to do? So I guess I'm curious what you think about, where some of the sort of useful pressure points are in affecting policies that really can make a difference in relation to, for example, the transition to heat pumps. Or, you made the point in your talk that we need now, whenever something, when you get a new car, when you get a new heater, when you build a new home, all these things, the right things need to be done. And that's policy, right? That's government saying, you got to put solar panels on this house and you got to have heat pump, not this. So what do you think? Where some useful
this
pressure
like
points? I'm curious what you think.
I've changed my thinking on this recently, and it's because of the pandemic. The analogy I like to, we pushed at these things, right? We give a little bit of incentive here. We give, a little policy change here, and we give some education and outreach on things there, right? And we hope that people change because of those small nudges. And it often doesn't work. There's a lot of inertia in the system, right? I mean, when I got my heat pump, I got 3 estimates, and every single one of the contractors was like, why do you want a heat pump? And then they were like, oh, I guess I can figure it out. And then they installed it wrong. And, this is a problem, right? We need thousands of people putting in heat pumps in California, like today, right? And every single one of the contractors has been working for decades doing the same thing. And there's a lot of inertia. And I like to think of the analogy with online learning. University of California, they have these highly impacted classrooms where there's not enough space for these courses where a lot of people need to take the same course, right? Like my intro mechanics course that engineers need to take. And so what they would do was give a lot of money. I got one of these grants to professors to develop an online course, and then to teach it. And I spent 2 years after getting that grant deciding, like, what's the optimal way to do this? How should I run this? What kind of software should this be? Should it be asynchronous? Should it not be asynchronous? And I was like, after like 2 years, had very little to show for it. Then the pandemic hit. And I had to teach a course, this fall online, big course, that course actually. And I still wasn't ready, even though I got that grant 1.5 years or more before this, and was thinking about these things. But just having the deadline and saying, you are doing this, made it happen. And it wasn't perfect, but it was, it's fine, and I'll continue to improve it. And it was just so interesting that the University of California had to throw a lot of money at this. And I put a lot of time just thinking about this and hesitating and not knowing how things were going to turn out. And But then all of a sudden we just had to do it, and we did it. And so I've changed a little bit in like, oh, we'll put a carbon price to incentivize, or we'll get some education out to these contractors. No, I honestly think that the policy should be we ban natural gas in every new building. Like that's going to happen in California. The Energy Commission is currently looking at it now. The University of California, by the way, did that last year. Every new building on campus, unless it's like specifically needed for research or something, there's no natural gas going into these buildings at all. And I think that's the most effective way. And it's weird because you are putting in place a policy that is, you're legislating a specific solution, which is problematic, right? You kind of want to say, we don't like carbon in the air. You figure out how to do it, right? The market will figure it out. But if you, I don't know, in this case, if you kind of know the solution or you're pretty close to the solution, this mandate is kind of what I think has to happen, because people figure it out. People educate themselves. People make it happen. We know it's viable. We just need to get over that inertia, I think.
Thank you.
Leo, you have your hand up. You have a question or comment you'd like to add?
Actually, from a little while ago, it was about still your involvement in university policy. And when you said that when you start complaining, people ask you to help. I've also experienced this myself, and now together with others, trying to bring up a sustainability committee for our institute. And we have 25 people who want to work on this, so it's really big. But we also see that for all these big decisions that you outline in your talk about heat pumps and solar panels and electric cars, and this requires so much managing and so much effort that it's too much for us to do this on top of our regular job, which already constrains us too much. So essentially what we really need is more people who have dedicated positions. And then I wanted to ask you again, is the position you have, are you actually being paid for doing these things for the university, or are you doing this because you like to do it? And if you are paid for that, sorry.
Yeah, so this is actually, I'm in a unique situation, and this came out of sort of the sustainability office in like 2015, late 2015 was disbanded suddenly during the holidays. And there was a committee to ask why, why did that happen and what should happen going forward? Because yeah, anyway, so what came out of that is that there was a new structure to our sustainability office when we kind of reinstated it. And there is an academic pillar to the sustainability office. So it's not just people in operations operating the campus. It's also the academics, right? It's education, it's research. And we are compensated. So I teach 3 quarters in a year, and I get teaching relief for 1 quarter. And I get a little bit of summer salary associated with it. So I am being compensated for my work. And so that's good, but it's certainly not enough, right? I mean, on the scale of what needs to be done, that's a very small amount. And I'm not saying I should be compensated more. I'm saying there should be, right, dedicated staff to doing this. And it's, I mean, that needs to happen. And there are a couple ways to do it. I think a groundswell of kind of activism from students really helps a lot. And also having a few advocates in upper administration and being in the room with them. If you can set up your sustainability committee where one of those people is the one that has, in charge of the purse strings and making all the big decisions. That is the case at UC Riverside. And he's generally an advocate of sustainability. Of course, he has financial constraints and whatnot, but he is an advocate. And it's really important to have those constant discussions between somebody very high up and the people who are kind of trying to speed up the transitions, right? Because sometimes it works out that your interests are aligned and you can make a lot of progress. They might be aligned for weird reasons, I can give some examples, but and sometimes you just, yeah, I have a lot to say about this. That it's very easy for people to also say, look, here are the constraints that I'm working with, right? When you talk to people above you, financial constraints, bureaucratic time constraints, whatever. And it's very frustrating because it's like, that's right. You are dealing with constraints that are put on you from above. Keep moving forward, keep moving up, send this complaint upward. We need to change these constraints. And if you're in the room with people with more power and influence, and you convince them to do the same with the above them, then you can start to make things happen, I think. So get those powerful people on your committee and make them listen.
Great. Jessica, you have a question? Go ahead.
You're muted.
You're still muted.
I was like, I have to find how to unmute myself after
Okay.
months of Zoom. Hi, thank you for being here. And I guess this is kind of going back into everything Leo said. I think of California. Adrian and I are both at SF State, and Alan as well. And we've been. It's funny that you said about UC Riverside having the thermostat thing, because here in San Francisco, there's the plastic bag ban and there's the straw ban and there's all these bans, but no one really lets it sink in as to why they're doing it. So like one of the ice cream shops had plastic straw ban, and then next to it nothing but plastic forks wrapped in plastic next to their signs. It's like you're really not getting them.
I have so many examples of this.
But it's I guess part of me is frustrated, especially with California, and I'm not from here. So as from an outsider, I'm just like, you talk all this stuff. When you're talking about moving up in the chain, and UC has such a powerful lobby, and the legislature in California also it's the California Council on Science and Technology, where it's advisors actually advising legislatures on this. And the Lieutenant Governor of California was appointed by Gavin Newsom to look into climate change and sustainability practices. And I just feel like, okay, everyone's talking about it, but no one's really doing it, right? Like no one's making those decisions and of saying like, this is just what we have to do. In fact, Gavin Newsom has been opening more leases for oil and gas exploration than like anyone over the past year. It's crazy what's happening here. And so I wonder, do you feel, and maybe this is just more of a rant, but do you feel in talking to your people at Riverside and saying that, move up the chain, are things really moving, or people are just saying, yeah, okay, and I don't know, do you have hope?
So, like I said, I think the activism from students is the most powerful thing. So we've had a lot of activism at the UC on a couple of things lately. One of them was divestment from fossil fuels. And there's a long history at the UC with apartheid in South Africa, right? So Berkeley was the first campus to, and University of California was the first that kind of broke the dam on divestment from apartheid. And so there's been a lot of activism on that, and it sort of worked. It was one of these things where the people who were being asked to divest were not particularly interested in hearing about that. Like that's not their job, right? But I think they also saw that it wasn't going to be particularly profitable either going forward to be investing in fossil fuels. And so we made the call maybe a little bit earlier than others, right? And so it was like this activism on a bunch of different scales that affected directly the person who needs to make the decision about divestment, but also indirectly shutting down coal power plants and decreasing demand for oil and gas on a larger scale that make these investments not as profitable anyway. I don't know. The activism works. It's just diffuse and pushing at a bunch of different in a bunch of different places all at once. But the narrative does change. And so now we have another thing that, being truly decarbonized, not carbon neutral, where we're buying offsets or relying on renewable natural gas instead of just really getting off of natural gas. And there's a petition with 3,500 students and staff that signed this petition. This is called the UC Green New Deal, and I'm part of this. This really came out of UC San Diego, and that we were in the room with the Office of the President on Friday, having a discussion with them about how to kind of move things forward and how to kind of update our goals based on the science and what's needed, right? And they're receptive. I mean, they have a lot of constraints, but they are receptive. And it's one of these things where it's like, okay, now how do we talk to the legislature? How do we work together, to move up in the chain to address the constraints?
We have to be patient and stubborn.
I'm wondering if we should should we have a lobby for legislature like that, and I feel like, to bring up the earlier point about astronomers not wanting to talk about it because we don't know the science, put in the comments, like everyone needs to talk about this all the time. And I think we overthink ourselves, and we're like, well, we don't want to do what someone else is doing, or it's like, no, like the voices that we're trying to fight against, they're not asking whether or not they're being too much or if too many people are saying, having the same message. So it's just like, I just want to bring everyone in, like, we have to be loud all the time. And do you think should we be organizing, just like start writing letters to the legislatures and nonstop, and try and get it that way, if going through the ranks isn't quite doing it?
Yeah, all of the above. No, I really appreciate that. Scientists generally, right? If we say something, we need to know precisely. Like I'm having this conversation, you're asking me about the efficiency of heat pumps, and I'm talking about carbon dioxide as a refrigerant as a function of the outdoor temperature. Like I kind of know, but I don't know everything, right? And I feel uncomfortable talking about it. But I know that there are people doing this in cold climates. I know that the basics of the heat pump technology and whatnot. And yeah, we need to, let that go. We know that we need to act, and climate change is an urgent crisis, and we need to act. And it's putting the burden on others and not on ourselves. We're causing it, and we're going to have very, fairly modest burden relative to nations that can't adjust and adapt, and so it's just highly unfair. And that was actually part of the discussion we had with the Office of the President, that it's incumbent upon us to take this action, because there's a lot of people who are suffering from it who can't do anything about it, right? So
Adrian,
and I think that
you had
that narrative with California legislators and the like-minded people, I think is actually pretty powerful.
Thanks, Ryan. Adrian, you wanted to add to that?
Yeah, I was just curious, Brian, because you've mentioned many things that sound really interesting that you're doing and UC is doing. Is that, information about what the activities are available anywhere where people could kind of see, get ideas of, we could do that too, anything?
Well, I mean, for the UC, there's a UC Green New Deal. You're at San Francisco State, is that right?
Mm-hmm.
Okay. Yeah, I don't actually know what's going on in the Cal State system at all.
Yeah, well, we've been talking about wanting to work on this front. So I think, gosh, if UC's been doing all this stuff, and maybe there's, we just don't fully know what's going on, but maybe so Jessica just put up the Green New Deal, the UC Green New Deal.
Yeah, there's that coalition. We got a whole Slack channel and stuff. Yep. But yeah, maybe we should be talking about Cal State as well. I mean,
yeah, it's a big system.
Building I'm sure you've got a lot more buildings.
26 universities in California.
Yeah.
Yeah, it's huge.
Yeah. That's a really good point. We probably should be expanding that coalition, right?
That'd be awesome.
Generally the legislature sort of fund, when there's an increase in funding and whatnot, it's going to both of them.
Yeah. And that would be terrific, Brian. Okay.
So Brian, being a little less California centric, so it sounds like first thing that people can do is to get on, if there's a sustainability committee or group at their camp, if they're at the university or their institution. So first off, what are some of the initiatives you're working on, and just in general, what do you think are the high impact items? I mean, we've all heard about getting rid of straws and things like that, which are, I think we can all agree, are mostly symbolic. Divestment is one that what you've mentioned already. What are some of the other high impact things that people can work on as far as being part of a sustainability effort at their institution?
Yeah, I think the highest impact per per amount of effort is just being noisy. It's not hard to write an email or make a phone call or go to some meeting and get in the room with people. That's really straightforward, and it requires, this is true with politicians too, but the people at upper administration and whatnot do not hear from that many students, right? And so if they hear from like a couple of % of the students, it is like, uh-oh, there's a problem, right? And it's a few %. This is true politically too, I think. And so I think that's the easiest thing to do. And I think the education, I think, is a really easy thing to do. I discuss these things. I talk about UC carbon neutrality initiative and where we're falling short, and where we might need to change. And again, it brings those students into the conversation, so they feel like they know a little bit more about it, are concerned a little bit more, and can be pointed in the right direction to help make change. I don't know. With us, honestly, I think I'm starting to work with the university with flying and disincentivizing flying. Right now, we are literally graded on how many colloquia and seminars we travel to give. And if it's international, then it's especially good. So if we fly especially far, it's extra points. And that's sort of problematic. But I guess maybe that'll take care of itself, because many of these can be converted to online without the university policy changing. But yeah, honestly, I think it's more about changing the system than individual choices, and being noisy and getting on these committees is what ultimately changes the system, right? You need a kind of a groundswell of activism, and that ultimately is making the really big decisions. However, it can be informed activism, right? There's a tendency, this is an urgent thing, and we need to do something about it now. And I'll look into this, and I'll find some stuff on the website, and I don't like that thing, and I'm going to be noisy about it. But I think it's really powerful to be informed and take a little bit of time, because occasionally there are points when you can act and it will have a huge impact. Whereas if you are acting on the first thing you see that doesn't have necessarily a huge impact, and the argument's not as good, then it's not as convincing. So this happened here at UC Riverside, where we were going to build this massive construction project, 18 new buildings, 2 million square feet, all dorms, basically. Just huge expansion of the university. And they were going to put gas into those buildings. And they were going to go just under the wire in meeting. The UC was saying that no more natural gas after this date. And they were just going to get in under that date with this massive expansion. And it happened to be a point where, I and others knew this is a point we should push on. This is a huge impact, and we can make this argument. And there are reasons why this argument might be effective, and it worked. And that's much more powerful than, going to, online, finding some information and yelling the next day about what you found, right? So get informed and find those pressure points. And it may take time before one pops up, right? It may be 6 months, it may be a year, but that's okay, right?
Well, that's interesting. So, and I think that's a great success story. And so,
yeah, and it wasn't just me, it was a lot of people. Like not just at the UC, right? This is like environmental groups that really pushed back in the process. In California, we have this CEQA process where we have these environmental impact reports that have to be submitted, and there has to be transparency about the effects of these new developments, and that allowed for this intervention, basically.
Interesting, fantastic.
Yeah.
Well, Brian, we've already taken an hour of your time, and I know we could all talk for many hours more. We already have. So I just want to say thank you so much for taking the time to do the Q&A. And, just one thing I'll mention as a shameless plug is you mentioned at the end of your talk, find groups to work with. And so, Astronomers for Planet Earth is one of those groups. And so,
absolutely.
So for those of you watching this who weren't part of the Q&A, please come join us, because we are trying to put our individual voices together to make collective change. So thank you all thank you, Brian, and thank you everyone for coming today. It's fantastic to see you all. And I know that I'll see you again soon.
Thanks, everybody. Thanks, Brian.
Yeah,
Thank you so much, Brian.
Thank you very much.
Thanks for listening.
If you're interested in Astronomers for Planet Earth, you can learn more at our website, astronomersforplanet.earth, and on social media as well. If you would like to be notified about future talks and events, please follow and join us.